Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna be using animation nodes to create like a simple cipher. Um, Basically, if you look at the description of cipher, cipher is a secret or a disguised way of writing or code. And in the Wikipedia, it means in cryptography, a cipher is an algorithm for performing encryption or decryption. So basically, if you have like a message that you want to hide from other person, and you kind of want to scramble the text in some way using certain like a key, cipher key, so that no one can read it unless they have that key. That's kind of like my short description of a cipher, my understanding of a cipher, and we can do that using Python. And but this one because it's a live noding, I want to do it using animation nodes, and I'll do a simple one. Actually, it's really good article. This is like the whole book from inventwithpython.com, chapter 14, exactly talking about it. Let's say you have like a message like, "Hello there, the keys of the house, blah blah blah." This system can actually scramble the text, so you get this kind of text, and nobody can read the text unless they have the key. And there's this thing called Cipher cipher. It's a really simple way to scramble like a text or letter simply by shifting the text. So if you have like A, B, C, D, E, etc., something until Z, A to Z, if you're shifting the alphabet by 3 space, you'll get this letter like D, E, F, G, H, I, J, etc. And I made the setup using animation nodes, and this is actually, it's already kind of working but there is limitations that you will see later. It only works with a uppercase. So if I have like A, B, C, D, E, and I want to shift the letter like by 5, I get F, G, H, I, J, which is actually, if we make it 3 space, D, D, F, G, H, D, E, F, G, H. So it's correct. So that's how you can shift the letter to do that, like a simple cipher. If I write like I love Blender and shift this, like we can shift it in a negative value or positive value, but we can get this kind of scrambled text very easily. Actually, there's also a limitation with this system that I have here. Every time I have space, it becomes A, or any other like special character. It doesn't actually convert properly, but anyway, you can still kind of read it. And if you shift it, you get this, and you give it to a person and say, "Hey, what are you writing?" Oh, actually, and if the person kind of want to read it properly, they want to kind of decrypt the text, they can do that by giving it the proper key value here. The shift, you see, it's being shifted back to the original message. So it says I love Blender, I love Blender. So yeah, this is like the message to give to the person. You just need to give the key. I think it's kind of, there's only like 26 variations that you can do here until you get to the one that to get the correct message. But anyway, yeah, this is actually one of the special case. It's a fun little exercise that you can do. Really, in reality, you probably this is something that's Python scripting or coding is really good at. It looks like you have a certain task and you want to kind of you make it to work in certain way. Basically, the idea is to be able to shift the letters, like text. And text, with text, we actually have like uppercase, lowercase, digit, and also like a special character like space or maybe like a dot. And the idea here is we want to be able to shift the character based on what's their type. Is it uppercase, lowercase, digit? What is exactly their type? And obviously we have in animation nodes we can actually get the characters lowercase, uppercase, and digit, and there's also special characters, and we can easily turn them into kind of like numbers. And there's a way to do that actually using Python. It's called the ordinand. So for example, you want to know the ordinand of A. A is actually number 65. And if I change to letter H is actually 72. And then if we know this number and we want to get it back, we can use the chr. This is another Python function. So these two functions kind of working together. If we basically make a text into their ordinand, and then if we want to scramble, kind of like shifting the text slightly within the format, we can do it this way. So for example, I have this like a message. What is the message? A-P-P-L-E. Okay, and we just want to shift it within their type, their uppercase. So we know that A, B, C, D. That's the like their order in a text, like L, M, N, O, and this is F, D, E, F, actually G, H. So Apple, if we shift it, it's become D, H, H, O, H, D, S, S, O, H. So if you try it, Apple, and kind of shifting it by 3 or by 3 backward, we get D, S, S, O, H. So that's the side, like the hidden message of this apple based on the if it's being shifted 3 letters. So that's the whole idea. It's really simple, and the way I do it in animation nodes is basically even though they look complex, they're not actually that complex. So basically what I did, I'm using this function ordinand and character to get to the number for the digit for whatever character we have. Letter A to Z. So A, so we can write it down here like A is actually 65 and Z is actually 90 if I'm not wrong. So Z is actually 90 here. This is actually Python. I'm using iPython notebook, and so I can kind of test like a small script. This is very cool little app called Pineapple. So I think you can download it for Mac and Linux. I'm not sure. Windows have it, but this is using the iPython notebook. And you can have like a small little script that you can write down, and you can also have like a markdown. You can write description, and you kind of test it and get the output right in the notebook. So it's an interactive Python, very handy. So I use this to write down what I need to do what I'm doing. So we know that A is 65 and Z is 90. That's mean from A to Z, we have actually this number 65 to 90. And knowing this, we can have like a list of this number 65, 66, 67 until 90. And whenever we want to do kind of shifting within this range, within the A to Z range, we can really shift it based on this list. So this is exactly what I did here. So I'm kind of let's see. First of all, okay, what I did, I know that I will be needing the ordinand and the character to get to the numbers of the characters. I actually made a script node for that. The script node itself is really, really simple. So this one turn a character to ordinand, and this one ordinand back to character. And the script for the character to ordinand looks like this. Basically, it's very, very simple. Integer ordinand string, exactly what I did here. From this function, ordinand of the string, we're gonna get back a number, an integer. So I can kind of doing a back and forth between character and numbers. And because we know the ordinand is like a sequence of number, I can basically shift this number. So this is, for example, this is the number that we have for A to Z. If we're doing like a shifted list, we get a new list that's being shifted, and basically by doing some kind of conversion from the original character, I can get to the like a shifted text. Let me try to actually explain this better. Which index? So there's another function that I use actually, which index. This is to find something within a list. This is also Python built-in functions that we can use. Let's say I have this list, my list 1, 4, 3, 12, 5. If I wanted to know which index number is number 12, it says index number 3, because 0, 1, 2, 3 is number 12. It will find the first within a list. Let's say I want to say, okay, I find number 8 in the list. It will give an error. There, number 8 is not in the list. Okay, that's actually what's happening here with the my list and index. This is another function, and I turn that into a script node as well. The script looks like this. So in order to do this, really, we only need those three functions. Ordinand, find the ordinand of a character. The CHR, from CHR find what character it is. Like, for example, 88. What is 88? 88 is uppercase X. For my setup, it's like I said, it's only working with a capital uppercase kind of character. We can write anything. Let's say like we write animations, and we shift it by 3, and we get DQLPD. So we have this weird letter, of course, and this weird letter, if we type it back, DQLPDRQ, and we shift it by 3 in the opposite direction, we get our message back animation. So this is the ciphertext, and this is the one. Is like I said, this is actually simply by shifting the character. Animation nodes come with a bunch of nodes that's dealing with text and also dealing with lists. So this is like really powerful. I can actually use this search list anyway. So if I have this example like hello world, and I want to do like a shifting, I can simply split the text into its own character, like HELLO, and then I can do like a shifting, and I can get this result. But of course, hello world being shifted on itself, it doesn't really, you know, it's kind of like a cipher as well, but you look at it and you kind of you can guess this is still like hello world, you know, unless it's shifting the list in a weird kind of way, unless the key itself is like a little bit more crazy, like if I can write it down. Let's say you have a key like 1, 2, 5, and like like random number. If this is become the key to do the shifting, it's gonna be a little bit harder to read this. So that's another way to do the cipher. But anyway, the one we are doing here is although it's a little bit complex, I will try to explain it now. So I provide some kind of message, okay? Like let's say sushi. The message is sushi. We want to scramble this text, and we can shift it in any way we want, but there's only like 26 combinations because we only have like 26 uppercase character or letter. So we shift it, like say shift it 8 by 8 or by 7, we get LN LAB, and nobody can guess this right away, but unless they know, they just need to shift it like 7 character back, they will find out about the message sushi. What I did here with the program, with the nodes, is I am splitting the text. First of all, splitting every character, okay, and then after I do that, I put it inside the loop, this guy, and the loop itself is this big thing that's happening. This is all the loop. I'll tidy up. I will use C and then kind of drawing the nodes and gonna move it. So this is our loop. Our character goes inside the loop, which is this string. First of all, what I did is turning the character into their ordinand. So they become a number, and the number is actually become one of these, from 65 to 90. The letter, I don't know what it is, I think SUS. We can try actually here. The ordinand of S, for example, is 83, and the ordinand of U is 85, for example. And I just need, all we need to do is kind of shifting that ordinand, but within the range. So that's what I did exactly. I have a shifted list. I have the original list, this guy, original list between 65 to 90. This is the range of A to Z in uppercase. And then this is the shifted list. We only need to work with the shifted list from now on. And whatever we do here, so based from the original list, I'm finding which index does it actually the letter belongs to. Like with sushi, U is 85, for example. U is 85. I don't know what's the index number, but it's over here. And comparing it with a shifted letter, this is actually the easiest way to do this. So this is the original range of ordinand of the character, and then this is a shifted ordinand, and based on the index, for example, U is 85. I think U is 85. Okay, 85 becomes 78. We're gonna get back N. So that's exactly what's happening here. Sushi become N, U become N. So and the loop, of course, does it all in one go. So whatever text we provide, it will convert everything automatically and very fast. And for every letter, no matter how long the letter is, the loop just gonna do the job. Snail, again, LGTBE, for example. That's the cipher. Sushi, snail, blender. I think blender is depending on how much we shift it. So this is blender. Of course, we can shift every word, for example, and it scrambled the text even more. It's become harder to read. But so that's basically the idea, simply by comparing the shifted list and the original list, and then we find which index we will find out the new scrambled text. And the next thing we do is, of course, I'm using like shift list, get list element, and then I use a lot of debug to see what's going on. And the output of all of the process goes back into the string, and then out of the loop we join the text back, and then output it into the text object. That's why whatever I write in here, it's become this guy. Okay, that's actually, yeah, that's the whole process. Hopefully I explain it clearly. Why am I doing this? It's I don't know, I think it's because it's fun, and it's also good to study the logic of programming, to understand the programming concept, and how kind of, if you're trying to write the whole program using Python, there's like a pros and cons about it. I believe this article actually have the solution. If you want to do this is Cipher Cipher. Where is the source code? This guy. So this is Cipher Cipher. Maximum key size. So this is the whole Python code to do it. Okay, it's like 57 lines, and it's a little bit more complicated when doing it this way, but of course this is like a one solutions to do it. There's another way. Sometimes a program like a how do I explain it? You have a problem, and then you want to solve it using like a program, like using Python script, and there are many solutions, but probably there's one that's really efficient, and sometimes the one that's really efficient maybe a little bit hard to read. Some of them like easier to read, but there are many solutions. But basically, if we are doing it using nodes, it's easier to kind of understand what's really going on, and then the way you approach it is really totally up to you. If you want to write it with a program, for me, I think if I'm doing it like using nodes, I kind of can understand what's going on easier. I'm kind of switching back and forth, and I don't need to worry about. I think the thing with the nodes is the whole thing is functional. Everything will just work. You just need to provide the input, and then you're expecting the output. As long as the whole process is right, it should just work. Even if there's an error, it's not like in a program. If there's an error, there's like a return value. But with the nodes, I think we don't need to worry too much about error. We're expecting it to just work. I probably should make like a few live noding videos that talk about simpler program, and then kind of comparing if you're coding it using Python and if you're doing noding in animation nodes or Squarechalk. But this is one of the example, one of like a real case program. Try to solve something using nodes, and this is the comparison using codes. I think with the codes, really, the idea is the same. First of all, here, like, it's defining all the functions, like to get the input from the user. What's the message you want to encrypt, or do you want to encrypt it, or you want to decrypt the message? And then there's this get key, and then translate the message. The actual program is actually is only this much of program, and it's using a lot of if. I think it's first of all, it's testing, is it alphanumeric, is it uppercase, or is it lowercase, and then check the ordinal, translate it, and simply by shifting it, and it gets the key back. It's kind of logical, and it's also actually fun to do it using Python. I don't know if we're using nodes make everything a little bit actually complicated, but for me this is actually simpler and more fun to do as well. And you can kind of display it on Blender because it's animation nodes, it's built for Blender. So I don't know, it's something for you to try. I'll give you the blend file because I cannot give the node tree. I'll give you the blend files for you to download and have a look. But yeah, I guess I have to try to do it using Python at some point. Remember that the whole key, the whole thing like this, you can just copy paste into animation nodes, believe it or not, and just use it as a script node. But of course you need to get rid of weird things like input, and I think you can use input as well in Blender, but you just tidy up the script and you put it into the script nodes, and the whole things can become just like a node. And you just need to put in the input. What is the input? The input is a message, and then this guy will do the encryption, and the output is going to be encrypted message. So, and you call the nodes maybe like a cipher code. Yeah, so that's a long life noding. Hopefully this is useful if you are beginner, intermediate. I don't know if you're like a long time programmers or you use nodes for a long time. This is probably a little bit funny, but for beginners maybe this can be useful. If you have any questions, suggestion, feedback, just let me know down below in the comments section. I guess I'll see you in the next video.